The cosmic void, solving the universe's biggest mysteries. Imagine this. The universe is not just expanding, but it's doing so in a way that might leave us feeling incredibly isolated. The concept of the universe's heat death or the potential destruction of our solar system by a supernova is already unsettling, but there's more. Scientists have discovered that the distribution of mass in the universe is accelerating outward, heading towards a lonely end. But here's where it gets controversial. The idea that Earth sits at the center of a region in the Milky Way with significantly lower mass density than expected is both fascinating and unsettling. This region is known as the local void. Now, a groundbreaking paper has emerged, claiming to have evidence that we indeed reside in this local void. The evidence comes from readings of the sound of the early universe. This sound is a metaphorical term referring to physical shock waves in the fluid of the post-Big Bang universe. These shock waves, known as Baryon acoustic oscillations (BAO), created the first concentrations of mass, which eventually formed the galaxies and galaxy superclusters we observe today. A simple graphic can illustrate how the cosmic microwave background (CMB) distribution of mass slowly coalesced into the universe as we know it. Credit E.M. Huff, Zosha Rostomian. The traces of these early oscillations are visible in the Big Bang's afterglow, known as the cosmic microwave background radiation. This data helps to map out the distribution of matter throughout the universe today. Previous research has shown that we are near the center of a vast region of the universe with an unusually low density of matter, about 20% lower than expected. One of the implications of this idea is that if matter density is a fifth lower in the void, gravity would also be a fifth weaker inside the void. This would cause matter within the void to accelerate outward faster than matter outside the void. The researchers present evidence that the last 20 years of BAO data support this thesis. Furthermore, they argue that this finding is more reliable because the local void hypothesis helps explain the so-called Hubble tension. This refers to the discrepancy where Hubble telescope data shows the universe expanding about 10% faster than theoretical calculations predict. The researchers suggest that if we live in a matter void, the unusually rapid acceleration of nearby matter would create the discrepancy known as the Hubble tension. This means the field has evidence that supports its own findings on two fronts. Observations align with the hypothesis that we live in a void, and the void hypothesis also explains the ongoing mystery of the Hubble tension. And this is the part most people miss. The implications of living in a local void are profound. It challenges our understanding of the universe's structure and expansion. It raises questions about the reliability of our current models and the need for new theories to explain these phenomena. So, what do you think? Does the idea of living in a local void make you feel more isolated, or does it spark a sense of wonder about the vastness of the universe? Share your thoughts in the comments below. Do you agree with the researchers' findings, or do you have a different interpretation? Let's discuss. New evidence. Are we living in a giant cosmic void? Hubble tension explained. What if everything we thought we knew about the universe was slightly off? New findings suggest that our planet, solar system, and even the Milky Way might be nestled in an enormous empty region of space, a cosmic void, that could change how we understand the universe's expansion. This revelation comes from groundbreaking research conducted by cosmologists at the University of Portsmouth and the University of St. Andrews. By analyzing ancient sound waves left over from the Big Bang, the explosive event that birthed the universe, they've uncovered evidence pointing to the existence of a vast, low-density void surrounding us. But here's where it gets controversial. This discovery doesn't just describe the structure of the cosmos. It also offers a potential explanation for one of modern science's biggest mysteries, known as Hubble tension. So what exactly is Hubble tension? At its core, it's a disagreement between different methods used to measure the rate at which the universe is expanding. Some measurements suggest a faster expansion rate than others, creating confusion among scientists. Could the answer lie in our location within the universe? According to Dr. Indranil Banik from the University of Portsmouth, The idea of living near the center of a massive void isn't far-fetched. In fact, it might resolve the discrepancy. Here's how it works. Imagine a giant bubble in space. But instead of being filled with air, it's mostly empty. This void has significantly less matter, about 20% lower density, than the average across the universe. Because of this imbalance, gravity pulls material toward the denser regions outside the void. Over time, this process causes the void to become even emptier. And here's the twist. As objects move further away due to this gravitational pull, their velocities appear higher than expected. This creates the illusion of a faster local expansion rate compared to the rest of the universe. Essentially, the void skews our perception of cosmic growth. To arrive at this conclusion, researchers analyzed decades' worth of data on baryon acoustic oscillations, BAOs, which are essentially echoes of sound waves from the universe's infancy. These oscillations act like a cosmic ruler, helping astronomers map distances and densities across the cosmos. After sifting through 20 years of observations, the team determined that a universe containing such a void is astronomically more probable, approximately 100 million times more likely than a universe without one. To put that into perspective, Dr. Bannock likens it to flipping a fair coin and having it land heads up 13 times consecutively. The odds against this happening are astronomical, making the case for the void incredibly compelling. These findings were recently published in the prestigious monthly notices of the Royal Astronomical Society in a paper titled Testing the Local Void Hypothesis Using Baryon Acoustic Oscillation Measurements Over the Last 20 Years. While the results are fascinating, they also raise intriguing questions. For instance, does this mean our position in the universe is unique? Or are there other voids scattered throughout the cosmos? And this is the part most people miss. If the void theory holds true, it challenges the assumption that the universe behaves uniformly everywhere. Now let's spark some debate. Do you think humanity's understanding of the universe will ever reach a point where no big surprises remain? Or does every new discovery simply open the door to deeper mysteries? Share your thoughts in the comments below. We'd love to hear whether you find this theory convincing or if you see flaws in the argument.